Hello, statistics student. This video is for chapter 4.1, discrete random variable. And to begin with, we will look at what is a random variable, and then we will talk more details of discrete random variable, which is the main focus of 4.1. And in 4.2, we will do application of discrete random variable. In 4.3, we will do one specific discrete random variable, which is binomial distribution. So what is random variable? Random variable is a variable x. Kind of like algebra, you use something that you don't know. You would give it a name x, but it has a single value, not by people assigning to you by substitution. It's determined by chance for an outcome of a procedures. So if you do a random procedures, there is an outcome and x changes. So I can do an example here. So here. And then out of all the random variable, we can classify them into discrete random variable and continuous random variable. So we'll talk about probability distribution later. Okay, so for example, what is the procedure? You toss a dice 10 times, and then you just look at when is 4 showing up. The number of times that 4 shows up is a discrete random variable. Okay, so let's do a demo. Here I have a dice. So it's if I toss it randomly, it will give me a number. Oh, I have 6 one times. No 4, right? Oh, 1 4. 3 times. Another 4. 4 times. Only 2 4. 5 times. 6 times. 7 times. 8 times. 9 times. 3 times. 3 4. The last one. Oh, 4 4. That many. Okay. So so I say I have 4 4. That's kind of interesting. But if I toss it another 10 times, I would have other times of 4, right? So x is equal to 4 once, but it could be different. And this x is determined by chance because I toss a dice and it's just sometimes it's 6, sometimes it's 3, sometimes it's 2. I might not have 4 4 my next time. So I could have all 4, I could have 0, I could have, what is the possible value? I could have x equal to 0, 1, 2, up to 10 because I tossed 10 times. I don't think this would happen, but I could have none of 4, right? All 10 of them are different numbers. I could have 10. In my case, I have 4 4. Another procedure would be weight of a student randomly select from a class. X is a continuous random variable because when I select a student and I ask he or her's weight, it's not a number that is finite. You can have any number in between 2 pounds, right? So you can have 150.23 pound or 120.11 pound. So it's infinitely many possible. So it is a continuous random variable. It's determined by chance. And something that has come up randomly could be you ask a friend and you think of how the friend contact you online. So some people, I have friends that only only Facebook message me. I have friends that only WhatsApp me. I have friends that only text message me. So there's different method that a friend can contact you. So the method that a friend contact you is a method, right? It's not a number, so it's not a random variable. It's something that is random, but it's not a random variable. Okay, so if x is a discrete random variable, we can display x and p of x in a table. Okay, so this table is called a probability distribution, and sometimes we call it probability distribution function also. But some book call it probability distribution function. Some book just call probability distribution. It's a table or formula so that you can, for every x, you can assign a p of x if it is a discrete random variable. Okay, here, this is the definition. Maybe I should switch this around. A PDF is of a discrete random variable is a table that gives probability of each value of x. So this is the example. I am counting the number of heads after I toss coin 2 times. A coin 2 times. So I have coins here. I toss 1 time is not a head, it's tail. I toss 2 times is another tail. I have 2 tails, but no head. So it'll be 0, right? So I have 0 number of heads I don't have, so 0 head. And it turns out that it's quite popular. I have 25% chance of having 0 head, 1 chance of having 1 head, no, 0.5 chance of having 1 head, etc. So you see how it tells you X is the number of heads after you toss 2 coins or toss a coin 2 times. You can put it in a table, you can put it in a graph also. For it a probability distribution to be valid, so you cannot just say, oh, just put together something. This is usually put together by calculating them theoretically, or actually do an experiment and do relative frequency, because that's how we do find probability of something, right? If we don't know how to calculate, we try a lot of times, and then it would if you try a lot, then this probability relative frequency would approach the real probability. So in order to check that it is a valid one, we do make sure that X is numerical. Make sure that sum of P of X equal to 1. This notation, sigma P of X, means you're adding all the sum of all P of X. So this is to avoid people just, did not give all the possible X and then just have some partial X and P of X shown. So it should be, it should cover all possible one, so that all the P of X would be 1. And then each value should be a valid probability. It means each value could be 0 and 1. 0 to 1. So let's do an example. So this one is valid, right? Because if I add 0.25 plus 0.5 plus 0.25, sigma P of X is equal to 1. So this is something that I would check first. Add together is 1. And then each one is between 0 and 1, between 0 and 1, and between 0 and 1. So it's a valid PDF. There's another one here. So this X is the number of medical tests a patient received after they admit into the hospital. So when a patient first admit into hospital, they would have to undergo some tests, maybe blood test or X-ray or whatever that is required. So they list out 1 test, 2 tests, 3 tests, 4 tests. So X is the number of tests. And then probability that you will receive 1 test is this, that you'll receive 2 tests is this, that you'll receive 3 tests is this. Now, is this a valid PDF? It looks really real, right? So let's try. Let's add them together. Are they equal to 1? If I do 0.02 plus 0.18, it's over here, plus 0.3. You don't need this. It is 0.9 only, not 1. So this is a partial 1 only. What could happen? Maybe someone did not do 5 or 6. They don't provide you. Could it be that it is missing 0? The 0 has to be there. It doesn't have to have 0. A lot of discrete random variable has X equal to 0. Like I do not get when I count the number of head, after I toss the coin 2 times, I don't have, so I get 0. But it could be 0 is not in this PDF. It could be any patient that admit in the hospital will receive at least 1 test. Maybe they would always have a blood test, or they would always have a whatever test that they will do. So, or urine test or something. So that's why 0 may not be there. So why is it not there? Why is it not equal to 0.9? We don't know. But if it is not a complete one, we cannot do some of the calculation on it later. So a typical question would be they'll give you a table and they'll ask you, is this a valid PDF? And you check by adding all of them. And then you check each individual one. If they're all between 0 and 1, and also the sum is 1, then it's valid. does not have to start from 0, but all the number has to be, finite, and also has to be like usually a count, usually. Okay, so if you had a valid PDF, there is something called parameters. There's 3 parameters that you can calculate from it, other than just finding x and p of x. One is called the mean, the other is called the variance, the third is called the standard deviations. So later on, we'll talk about what they're useful for. Mean is very useful. Actually, mean has another name called expected value. So it's also called E of x, expected value of x, expected value of x. And in terms of symbol, it's called mu. Similar to in data, when you have population mean, it's called mu. But this is purely not data, so it's just coincidentally they use the same symbol. Mu is the mean of the probability distribution. How do you find it? Oh, it is actually sigma, xp of x. That means if you have this table, you multiply these two together, x times this, x times this, x times this, x times this. You have 4 number multiplied together, so 4 product, and then you add them together. Okay, xp of x, and then add them together, and it becomes the mean of that. Now, mean is very important. It is actually called it's a long-term outcome of the average of x. That means on average, if you repeat this, do the procedure a lot of times, sometimes you have one, like if you repeat looking at the patients, you keep on repeating, on average, what would be the number of tests that a patient would receive? Only if it's a valid probability distribution. If it's not a valid one, this doesn't apply. So must be a valid one. And then there is 2 other one that describe how the x value is spread out. One is called standard deviation. This will actually talk about how it's spread out. The way to calculate it is just like in data. Each x value minus the mean, square it, and times p of x. So this is a lot of calculation if you are to do it by hand. Sigma square is called variance. It's just the square of the standard deviation before you take the square root. So you can calculate these parameter by going easycalculation.com discrete random variable, and the link is over here. Okay, so when we do an example, we'll look at how to do this. The most important one, of course, is the expected value of x. It tells you if this repeat a lot of time, what is the mean average of x. And then there is one more important basic concept is called non-significant values of x. So if you look at a PDFs, sometimes some x are very likely to happen, some x has low probability, some x has high probability. How do I know what values are usually I will see, and what values are not usual? Like last time I have 4. I think that is quite unusual, right? So non-significant values are the one that is usual. That means they're likely to happen. You're likely to see these x, likely to occur, that you will not be surprised. So the range is just like in data. The normal range is, the usual range is mu minus 2 sigma to mu plus 2 sigma. 2 standard deviation away from the mean. And we call it is based on range rule of thumb. So if they ask you to calculate, please calculate the non-significant value. You will calculate mu minus 2 sigma to mu plus 2 sigma. Values that are outside of this range are significant. They are unlikely to happen, and you will be surprised to see them, right? So by looking at a PDF, you can actually see what do I expect to see, what do I not expect to see. So we'll do examples in the next video.